Welcome. In this video, I'm going to help you find the equation of a sphere. And now we're given the centers at -1, 3, 2, and it contains 0.24, -5. Okay, in order to continue, let's recall that the equation of a sphere with a particular center, so let's say, sphere with radius r and center x naught, y naught, z naught. Well, we can write this out as r squared equals x minus x naught squared plus y minus y naught squared plus z minus z naught squared. And in this case, this is x naught, this is y naught, this is z naught. And we don't know what our radius is, so let's not worry about that right now. Let's just go ahead and fill in what we do know. So r squared is equal to x minus -1 squared plus y minus 3 squared plus z minus 2 quantity squared. Now, a negative minus a negative is a positive, so I'll rewrite this just one more time before we continue. Please do not underestimate the value of neat and organized work. So the last thing we need here is the radius. We're not given a radius, but we are given this other point here, 2, 4, 5. So I can replace this x value of 2 here, this y value of 4 here, and the z value of 5 here. Let's go ahead and take care of that. And I'm going to color code these blue, pink, and green. So r squared is equal to 2 plus 1 squared plus 4 minus 3 squared plus -5 minus 2 squared. So r squared is equal to 3 squared plus 1 squared plus -7 squared. So our radius squared is 9 plus 1 plus 49. That gives me a radius squared of 59. So to recap, the first thing we did here is, so this was 1, use center in equation for sphere. The second thing we did here was use other point to help solve for r. And now that we have r, we know that this sphere is given by 59 is equal to x plus 1 quantity squared plus y minus 3 quantity squared plus z minus 2 squared. Okay, and now let's quickly graph this and just make sure our work makes sense. So as you can see here, I went to geogebra.org. And you want to click on this little 3x3 grid of squares and pop into GeoGebra Classic. There's all sorts of other calculators you can use, but GeoGebra Classic has the best functionality. So I would stick to Classic. And then go to 3D Graphics here. And as you can see, here's the red is X, green is Y, and blue is Z. If you struggle to see that, all you really need to do is do this. Go 1, 0, 0. That's your x-axis. And then you can even rename it. I can go to settings, and under settings, I can use caption x-axis. In fact, if you use any of the applets I create for my Calc 3 class, the labels I have for the x and y axes, this is how I create them. So let's do it here for 3, and then let's go with color. I'll change it to red. And then the style, I always make the point nothing. So it's just like an x-axis label. And I'll just leave the one label. I think that's enough for now. But at least you know how to create your own labels. You can move it around from here. You can do the same thing for the y-axis. Just do 0, 3, 0, or 0, 5, 0, whatever you want this to be. And the same for the z-axis. So what we want to do is verify that we actually found the equation for a sphere with a center at -1, 3, 2, containing the point 2, 4, -5. So I'm going to go ahead and go 59, which is the square of the radius. So 59 equals oops, 59 equals, there we are, x plus 1 quantity squared. And then if you keep typing here, you'll get it, you'll keep typing within the exponents. You want to use a right arrow on your keyboard to get out of that. And then you want to add to that y minus 3 quantity squared. And then you want to add to that z minus 2, and again, quantity squared. And there we have the sphere. And so let's double check if this is correct, right? So the first thing I'm going to do is I'm going to check that it contains the point. So 2, 4, negative 5. And here's this point. I'm going to rotate my 3D graphics view. And let's see. Let's see if that looks like it's in there. Ooh, that was a bad rotation. Let me try this again. Let me zoom out first. And now let me rotate. And that looks like this point is in here. Look at that. It is on that sphere. Now, if you want to verify that this equation is correct, you can go here and you can go to this icon that looks like a sphere, or looks like a circle really, but they shade it to look like a sphere. And let's go sphere with center and radius. So, I should start with the point. Excuse me. Let me hit escape. I hit escape to go back to this arrow, and I'm going to put in my center of negative 1, 3, 2. Okay, and I want to hide this point, and I want to hide this here. So now I'm going to go back sphere with a center and radius. So I'm going to click on that center, and the radius I'm going to put square root 59, because remember our radius squared is 59. And here we go. If you notice, we get the exact same equation that we had here: x plus 1, y minus 3, z minus 2. Each of these individual quantities squared equals 59. And that is indeed what we wanted. I hope you found this video helpful.